right, so I'm going to go through the engineering design process report, which I'm going to have you go through for the structural design. It's going to walk you through the engineering design process as you solve this design problem. I'll have a summary document to go with this. That'll be sort of your introduction to the assignment, but this is going to be the template for your final report. Previous to all that, you'll see sort of me going through the engineering design process with a little home project that I did back in March. So the top of this is all set for you. You don't have to change anything. I do want you to try to change this picture. Put something that's relevant to the project, and you can pick something. Just put something different. Obviously, your name, that stuff, self-explanatory. This right here will automatically update if you click on it and hit update table. It's going to look a little bit different if you're using this in a Google Doc versus Word, but you should just be able to update the entire table and everything will come out okay. Now, the way this works, you need to do two things to not mess it up. Don't type anything. Don't add anything. Just you can click on it and update table. That's all. And then just leave it as is. The way that works is based on these text that's in kind of a bolder font. Don't change the font. Don't delete these. Don't add things with them. It's based on, these are what's called a heading. And you see up here, heading 1, heading 2. And then the magic of it is this is an automatically generated table. What's going to be nice about that is as you add more pages to some of the sections, these will automatically update, which is really cool. So you don't have to go change the page numbers. It will do it for you as long as you don't mess up the formatting. So you're going to download your own copy. And I'm going to go through and explain what these sections are. Some of them are self-explanatory from watching the previous series on how the engineering design process works. But I just want you to understand this document because this is what you're reporting in. You'll submit this document a few times, just different progress updates, so I can give you feedback as you go through it. So define the problem. This is just a one-sentence summary of what is the problem, a real quick, what do you have to do? The criteria is what do you have to do to be successful? So if this is the build a tower scenario, the tower has to hold a shoe, which is what I deemed as the only object that I can ask everyone to put on top of their tower, and I believe everyone should be able to do that. I was thinking weights and cans and things, but I'm not sure what people actually have in their houses, so I'm just we'll do a shoe. Constraints is limitations, for example, and there's going to be more than just the one criteria. The constraints are things you can't do. So you can't tape this or glue this to a table. You can't support this and lean this up against a wall. So that would be a constraint. Sometimes you can word something as the criteria is it has to be freestanding, but a constraint is it can't be supported by something outside. So that could go kind of either way on that one. Research and investigation, just find a bunch of pictures, find text. What makes a good structure? You're using limited materials that are not by themselves particularly strong. Not that a shoe is particularly heavy, but this tower needs to support itself and not tip over, fall over, or break. Because it is going to be a little bit taller. So those structural members can bend and snap. So look at what makes a good structure. If you have any sources, you can do the MLA formatting you're doing in English class, but at least for this, just do a link if you don't want to do the MLA formatting. But this should be just a bunch of pictures and a bunch of stuff that is going to give you information to do your solutions. You're going to generate 5 different solutions. They are going to be either 3-dimensional drawings, such as an isometric, or a 1-point perspective, something like that, to represent what you want to build. And they need to be different because I'm going to have you pick from those 5 designs, but you do need 5 designs to make your decision. So that is in the generate solution step. In the evaluate and select step, you are going to have those 5 solutions, and you're going to pick the one that is the best based on grading each of them separately by these 3 things. If at all possible, try to kind of rank them a little bit. So ease of construction, if you have 5 designs, they shouldn't all be the same ease of construction. Some are going to be harder to build. Maybe you have to cut more pieces, glue more joints, etc. So that might not be as easy. So out of 10, something that has a lot of small pieces might be, a 3 or a 5. Something that's, 2 or 3 pieces going across, that's going to be pretty easy. That might be a 9 or a 10. Material use, you do have limited materials. I did provide enough materials to do this. However, if you think that it's going to take up a lot of different material, like just might not have enough material, and some of this is assumed, so a simple design maybe will use less material, but it wouldn't necessarily be assumed as strong, but it might be better at material use. A really complicated design that has maybe doubled up sections is going to consume more material, and you may not have enough. So you have to judge that sort of at the get-go here. So assume strength, again, this is sort of you just guessing. If it looks like something that has an example that is really strong, maybe you assume it's stronger. Try to rank them at what you think they'll be the strongest, where 10 may be the strongest of your designs, and then 5 would be the weakest, in whatever order they are. Then you'll add up those scores, and then whichever one has the highest score will be the one that you're going to go and actually plan for. So these are just sketches so far. Now, when you get to the plan, that's when you're going to watch the video I have on how to lay out and create your tower. That is going to be a full-size drawing that is going to help you cut the pieces to length, lay out the pieces where they're supposed to be, and glue them in place. But the planning step, you are going to just put a picture of your final plan. The paper plans do get damaged and sometimes destroyed in the process of making these towers. So you're not going to be able to necessarily show me what they look like after you build a tower. So before you create it or glue anything to it, I want you to take a picture, and that's going to go in the plan step for this design challenge. For create, any day that you're working, I just want you to answer these 3 questions. And then, so the dates, you're working on it. This is just so I kind of see how you're managing your time a little bit. What did you do yesterday? If it's the first day, obviously you don't have anything. What do you want to do today? So you're going to work on this kind of at the beginning of the class, because I am anticipating you're only using the class time to do it. So do this before you start work for the day. So today I want to cut out the pieces for my design. And then what is getting in the way, trying to determine what's going to cut the material the best, what's pair of scissors, whatever. So that's, potential problem, anticipated problem, etc. Then the next day, what did you do yesterday? This can differ. So if today you said cut all of the materials, maybe you say, what did you do yesterday? I only cut some of the materials, and that's fine. I just kind of get to see, how you're thinking through it. And then maybe today's problem is different than yesterday's problem. And they don't have to be sequential days, but it'll just be kind of a log of the things that you got done. There'll be a sentence or 2 for each of those answers, and you'll just go through and do those for the days that you're working on it. It may only be 4 or 5 work days in this, and that's fine. Once you're done constructing it, you're going to take a picture of just the tower before you do anything with it. Just it is physically in one piece. You're going to take a picture and put it in there. Test and evaluate. This will be a picture of your tower supporting a shoe, 8.5 inches, 8.5 inches above the table. Take the photo from a couple different angles so I can see like all the sides of it off the tower. And 8.5 by 11 is just the shorter side of a piece. 8.5 is just the shorter side of a piece of paper. And this is part of the assignment in the video. I'll show you how to do that for construction. And then just a little reflection. How does it work? Is it different from your original plan? Did you decide to cut things differently? Did it build differently than you thought it would be? Does it meet your success criteria? Then for optimize and evaluate, if you had more time, what would you do differently? If you had a new set of materials, what would you do differently? What would have helped you overcome the problem that you faced, like in this category? And if you had to do it all over again, what would you do differently? So those are just reflection questions there. The present step in this document or for this project is going to be submitting this report to me. So just turn it in. And then if you want to link your websites down here, that you find stuff. You can do that too. I'm okay if the work cited, or the sources are down here or up in the research section. Either way is fine with me. So that is the talk through of this document. Please let me know if you have any questions. Thank you.